Okay, I'm going to change my screen so that we can begin with the class.
Miss, what page?
Is page P14. Today is February 25th, 2021. Lesson 0,4 and roots and real exponents. Objective: simplify expressions in radical forms. Simplify expressions in exponential form. Well, it doesn't move. Book page P14. Okay, lesson 0.4, nth roots and real exponents. What are we going to do today? We are going to simplify expressions in radical form, and we are going to simplify expressions in exponential form. Many are the solutions that the world can offer, but only one is the real solution. His name is Jesus. Okay? That is our Bible principle for today. Let's begin with some review exercises here. So let's write as a title, warm-up exercises. That is the instruction, simplify. Number 1. Okay. When you are in 8th grade, you learn about simplifying radical expressions. You learn about perfect square roots, and you learn how to simplify radical expressions that contain variables, okay, and exponents. And very little, but we saw it, we learn about cubic roots. Now, I would like to ask Marvin Espinal. Marvin, what is the value of the square root of 4?
2.
Just 2?
Positive and negative 2.
Very good. Elim, what is the value of the square root of 25?
5.
Just 5?
I'm not sure, Miss.
Okay, when you find the square root of a number, it's positive and negative, always. 5. Now, 63 has no perfect square root, as far as I know. But we can factor 63 as 9 times 7. Do we agree? Or am I mistaken?
You mean positive and negative, or it doesn't need to have there.
No, yes, but I'm still simplifying, don't worry. I can separate this as the square root of 9 times the square root of 7. 9 has a perfect square root, as Wilfredo said, positive and negative 3 square root of 7. And this is your answer, okay? Now, this is an x. When you have this 4x squared, we can separate the square root of 4 times the square root of x squared. Now, important data that you should know and that you should remember, because we learned this in 8th grade. That's why I asked you to print the law of exponents. If you have the square root of x, you can rewrite this as x to the 1/2. If you have a radical expression, you can this is a b. This is a b. You can rewrite this radical expression using rational exponents. X b over a. If by any chance you have this, you can rewrite this radical expression as x to the square times 1/2. See, because the square root of x is x to the 1/2. And you have it to the square. Remember the law of exponents, power of a power? How much is 2 times 1/2?
1.
So you have just x. Important. This is something that you should know by now, but if you don't remember, write it down, because this will help you in this lesson. If you know this, this will help you in this lesson a lot. Okay, so let's go back to the problem. I'm sorry. I'm going to try to erase this line.
I already took a screenshot.
I don't know. It always happens. Have you noticed that it always happens?
I will send a screenshot to the group. Don't worry.
Wait, I'm just going to write the Bible principle, because that one I really care about. Bible. Not that I don't care about the objectives, right? But the objectives are in the book. At the very top of the book. So if you didn't copy them from the screen, you can copy them from the book. But the Bible principle, no. Okay, right there. So let's continue. Is equal, here. This must be equal to 2, because the square root of 4 is 2, positive and negative 2. And the square root of x squared, well, you have it here, is x. So the square root of 4x squared is positive and negative 2x. Now, the square root of negative 27. It's an imaginary number, right?
It will be
just imaginary.
I to the square 9 times 3, I think.
So we will have negative 1 times 9 times 3. You already know, I'm going to write it again here so that you remember that negative 1, the square root of negative 1 is I. So that means that you can separate this as negative 1 times 9 times the square root of 3. So it's a square root, positive and negative 3i square root of 3. Now, notice that this is the cubic root of negative 27. If I factor negative 27, I can factor it as negative 3 times 3 times 3. Do we agree? 3 times 3 is 9 and 9 times 3 is 27. And because one of them is negative, so you factor it out. Do we agree? And it's to the cube. So I can
you repeat that? Can you repeat?
Okay, negative 27 can be written as negative 3 times 3 times 3. 3 times 3 is 9 and 9 times 3 is 27. And because it's negative, one of them will be negative, right? So you can factor this as negative 1 times 3 to the cube. Do we agree? Elvia, do we agree? That,
Yes.
okay. And this negative 1, I want you to look in the calculator. You can't find the square root of a negative number, but it's possible to find the cubic root of a negative number. So tell me, what is the cubic root of negative 1?
Negative 1.
Negative 1.
Negative 1.
And these 3 will go with this 3. So your answer is negative 3. Just negative 3. Now
Yes,
you
but
can find this. Sorry?
I have a question. Where did the negative 1 come from?
Because any number multiplied by negative 1 will be the negative number, right? So these 3 right here, it's negative. So instead of writing negative 3, I wrote negative 1 times 3 to the cube. 1, 2, 3, 3 to the cube times negative 1.
Thank you.
It's an invisible 1. I made it visible. Every time that you have this, okay, write it down. Another important fact. If you have negative x, you can rewrite this as negative 1 times x. There is an invisible 1 here, so you can make it visible. For factoring purposes, this can help you a lot. Another factoring purpose that you can use is that if you only have x, that is like having 1 times x. This is known as invisible math because that 1 is there even though you don't see it. So you make it visible. Okie dokies. Did everyone copy this? Because I need the space and I have to erase. I hope. I don't know why. Every time that I touch even close, it erases. I really don't know.
Miss, ¿no será que tiene la sensibilidad del mouse bastante alta?
Maybe. Or maybe because this window is too big. I have to make it smaller. See, the window ends here. Even though I don't see it, it ends here. So that means that if I barely touch it, it's gonna close, it's gonna erase. So I have to make it very small. Let's see if I can make it smaller. No, I can make her smaller. So I'm going to make it, I'm gonna move it up right there. Okay. Now we are going to be working with nth roots. Okay, let's work with the nth roots. I would like Irene. Irene, do you have your book?
Yes.
Okay, can you please read at the very top, simplifying radicals?
Simplify radicals. A square root of a number is one of two equal factors of that number. For example, 4 is a square root of 16 because 4 times 4 or 4 to the square is equal to 16. In general, if a and b are real numbers and n is a positive integer greater than 1, if b and a equal
B to
a,
the n.
then
B to the n.
b equal to the n, equal A, then B is an nth root of A.
Okay, so that definition is important. So we are going to write it down here, okay? We're gonna write nth root of a number. I'm going to make my line here because these were my warm-up exercises. Now we're going to the class. If you have b to the n equal to a, okay, this b is known as the nth root of a. When you have a radical expression, this is known as a radical expression. This n is known as the index, and this is known as the radicand, okay? Now, the value of a depends on the value of n. If n is even, okay, if the value of a, I'm reading the chart for real nth roots of real numbers in the same page. If n is even, which are the even numbers, guys? Let's see if you remember which are the even numbers.
2, 4.
2, 4, 6, 8, 10, and so on. If n is an even number and a is greater than 0, for n even number, for the value of a greater than 0, that means a positive number, okay? You will have two roots, a positive and a negative. If the value of a is less than 0, that means that you have no real roots. That means that if you have the quartic root of -4, that won't happen, okay? And if the value of a is equal to 0, you only have one real root, and that will be a equal to 0. Now, if you have that n is an odd number, which are the odd numbers, guys? Let's see if you remember.
1, 3, 5.
1, 3, 5, 7. If the value of a is greater than 0, that means a positive number, you are just going to have one positive root, and 0 negative roots. Okay? If the value of a is less than 0, you are going to have 0 positive roots and only one negative root. This corresponds to exercise number 6. Look, the value of n is an odd number, 3. And the value of a is a negative number. That means that it's less than 0. How many roots do you have? Only one, and it's negative. It was -3. Okay? And if the value of a is equal to 0, well, you're going to get just one real root, 0. If the value of n is positive and even, you get 2 real roots. If the value of n is even and negative, you don't have real roots. If the value of n is odd and positive, you only get one positive real root. And if the value of n, this is n, look, the index, it's less than 0, that means negative, you are going to get one negative root. Okay? Let's do some examples. I'm going to erase this where it says warm-up exercise so that we can do the examples. Hurry up, Celeste. Okay. Examples. Evaluate each expression. Negative square root of 81. Quartic root of 16 over 625. And the sixth root of negative 243. Okay, this is a real number because the negative is outside. The exponent is 2, so that means that you can find the square root of 81. What is the square root of 81?
It will be negative
Positive and
9.
negative one.
No,
Nine.
it will be negative 9 because
Only
it
negative.
Negative.
Because you
because
have
it's
a negative.
affected by the outside sign.
Aha, exactly. So you have negative 9. That would be your answer. As simple as that. Negative 9. Now, you have the quartic root of 16 and 625. It's the value of n is even. And it's greater than 0. The value of a is greater than 0. That means that I will have 2 roots. Not only the square roots are positive and negative, also all of the even roots, okay? So I can rewrite this as the quartic root of 16 divided by the quartic root of 5. Sorry, of 625. So tell me, which is the value of the quartic root of 16? Come on, guys, you have a calculator. Use it. Or you don't know how to find the quartic root.
Is 2.
It's 2. Very good. Positive and negative 2. And what is the quartic root of 625?
5.
It's 5. 2 over 5. Positive divided by positive, positive, negative divided by negative, positive, positive divided by positive, positive. Okay, now, the index is even. Look, 6 is an even number, but the value that you have inside, it's negative. So if I go here, the index is even, but the value of a is less than 0. That means that we do not have real roots. So we are going to write here, not a real number.
Miss.
Yes.
So basically, we can, and the square root can never be a negative number.
Excellent. There can never be a negative number inside a square root because that will give you a imaginary
So
solution.
it
No
only
real
have,
solution.
if it's negative, it only have to be outside of the square root.
If it's negative, it has to be outside. So that you can solve it, like in example number 1, letter A. If it's inside, like in example letter C, then you will have an imaginary number and you will have to use the letter I.
Okay, thank you.
If it's negative, then it's not a real number.
So
Yes,
when
if you have a negative inside an even radicand, then it's not a real number. It will give you an imaginary root. Imaginary. Okay. Let's continue.
Miss,
Yes.
so when do we know when to leave it I mean, want to leave the answer as an imaginary number and want to put not a real number.
Well, in this particular case, for matter of time, we're going to write it as not a real number, okay? But you can find, for example, in this case, you have the 6th root. And if you remember working with complex numbers and imaginary numbers, what I have is the square root of -1 is equal to I. And this is not a square root. It's 6. Okay, so I cannot leave it as an imaginary number right here because it's a 6th root. And I will need a square root. So if you are not working with square roots, just leave your answer as not a real number. When you are simplifying using square roots, then you can use the letter I, the imaginary number I, okay? In this case, just write not a real number because it's a 6th root. And this is what we know, that the square root of -1 is equal to I. It doesn't say the 6th root of -1 is equal to I. Did I explain myself, Sarah? Or did I leave you more confused?
Oh, yes, thank you.
Okay. Simplify each expression. We have the 8th root of B to the 24. The 6th root, see, we're working with higher order roots here. 64 parentheses y plus 2 to the exponent 30. Letter C, the square root of 48 x to the power of 5. And the last problem, let's see if we have time. If we don't have time, we'll do it Monday. The cubic root of -27 a to the power of 6, b to the cube, c to the power of 5. Okay.
Miss, that's a 30.
Yes, it's a 30. It's a 30. It looks like a 20, right? But no, it's a 30. 3. Ah! I did nothing. Okay. Remember that at the beginning of the class, I asked you to copy some important information that I will rewrite again. I told you that if you have this, you can rewrite it as x b over a. And that is exactly the property that I will use for letter A. These are known as rational exponents. So that means that I can rewrite b with an exponent of 24 divided by 8. And this, you can simplify it as b to the cube. And you're done. You already simplified the expression. Okay? Now, letter B, remember that there is a property for multiplying radicals that tells you that if you have the product of 2 radicands, you can write each radicand under a single radical. Okay? If you have x times y, you can write it as the square root of x times the square root of y. And that also applies, sorry, I'm gonna write here the index, n and n. This doesn't work only for square roots. It works for whatever radical with any index that you have. That means that I am going to use this property here. I'm gonna write the 6th root of 64 times the 6th root of y plus 2 to the exponent 30. Now, 64. Get your calculator and tell me if you can find the 6th root of 64.
Is positive and negative 2.
Mhm. Okay, let's say that it's at the absolute value, okay? Well, no, let's say it's positive and negative 2, okay. Okay, now I am going to use this property in here. Y plus 2, 30 divided by 6. How much is 30 divided by 6?
5.
Y plus 2 to the power of 5. And I'm done.
Miss, I have a question.
Tell me.
If I solve that exercise but in a different way and give me the same result,
It doesn't matter.
because the thing I do is that I get the factors out of 30 that was 5 and 6, and then I cancel the power of 6 and was 64 to and like that.
No, it's okay. I know what you're doing. What you did is that you wrote it like this. 2 to the power of 6 and y plus 2, and this is 6 times 5. So that means that you cancel this one with this one with this one, and that will be left just with y plus 2 to the power of 5. Exactly the answer that we got. So it doesn't matter, okay? At the end, the answer is the same. It doesn't matter the method. Okay, letter C. 48. We need to look for the square root of 48, x to the power of 5. So let's write this. 48 has no perfect square root, but I can write 48 as 16 times 3. Yes or no? And x to the power of 5, I can write it as x4 times x. 16 times 3 is 48. And x4 times x will be x5. Until there, are we clear? Yes? Okay. Now let's find the perfect square root. The perfect square root of 16 is positive and negative 4. X to the power of 4, listen carefully, guys. If you have the square root of x to the power of 4, you can rewrite this as x4 divided by 2. 4 divided by 2, and that gives you x squared. Now, 3 has no perfect square root, it will have to stay inside. X has no perfect square root, it will have to stay inside. Okay? And this is your answer. 4x squared, square root of 3x. We do not have time for letter D. So that means that on Monday, we are going to continue with this topic. I thought that we were going to see it in just one day, but I see that it requires a little bit more of practice. So I'm going to stop sharing my screen right now because I have less than a minute for the class to finish. If you didn't get the chance to copy these last exercises, remember that the class is being recorded. You will find the link to this class at the end of the day. Study your lessons for tomorrow, and we are going to see each other if at once for tomorrow's classwork. Bye-bye. Take care.
Bye, Miss.
Bye.
I miss.
Bye.
I miss enjoy your meal.
You too. Bye.